Okay, here's mock quiz number 3 for math 2. So for number 1, you guys, first it's important to know that you have to take the opposite of the here's this right triangle. Now, remember, we're in the perspective of this angle, which means that this x is opposite, this y is your adjacent, and this 12 is your guys' hypotenuse. Okay? So it's important to know that so that we know which trig function to use when we solve for this x and y value. Okay, so we know that this information has O and H, so that means we're going to be using sine of 25 is equal to the opposite, which is x, over the hypotenuse, which is 12. And then from there, you guys, you just have to cross multiply. So x times 1 is x, 12 times sine of 25 is 12 sine 25. And then put that into your calculator for x to be estimated to be 5.1. All right, so now let's use our right triangle to find our y value. Well, this y has an a, and this 12 has an h. So since we're in the perspective of this angle, we are going to use cosine to solve for y. So cosine of 25 is adjacent over hypotenuse, so y over 12. Okay. And then we cross multiply, which means we do 1 times y for y, and 12 times cosine 25 for 12 cosine 25. And then put that into your guys' calculator, and you should get y is roughly to be 10.9. Part B, same deal. So in the perspective of this angle, I know 6 is the opposite, right? This is the opposite side. X is your adjacent, and y is your hypotenuse. So then I'm going to use tan 50 for 6 over x to solve for x, right? Because tan is opposite over adjacent. So then put it over 1 and then cross multiply. So x times tan 50 is tan 50, and 6 times 1 is 6. Now to isolate our x, we have to divide both sides by tan of 50. So then we're going to get x is roughly 5.0, rounding to the nearest tenth. Okay, now going back to the right triangle, in the perspective of this one, right? To solve for y, we do opposite, and we're going to use the hypotenuse. So sine of 50 is equal to 6 over y, opposite over hypotenuse. Sine is equal to opposite over hypotenuse. Then we go over here and we cross multiply, so we get y sine of 50 equals 6. Divide both sides by sine of 50, and we're going to get y is roughly 7.8. So that's number 1. Number 2, so you have this angle, right? So you're finding angle measurement. So label all your sides. So this side's opposite, this side's adjacent, and this side's hypotenuse. So in order to find our angle measurement, find where we have information, right? Well, we have information here and we have information here. So that means we are going to be using sine. Sine theta is equal to opposite over hypotenuse for 15 over 17. And then to get rid of or to isolate our theta, just sine inverse to both sides. And then sine inverse of 15 over 17 in your calculator will be 61.9 degrees. Okay. B, same deal. So that's theta. This is opposite over opposite and adjacent. So the one trig identity or function that uses opposite and adjacent is tangent. So tan theta is equal to opposite over adjacent, 11 over 12. Take the tan inverse of both sides to get tan inverse of 11 over 12. So then theta is going to be roughly 42.5 degrees. Okay, here's number 3. So this one has a drawing for you guys. So the ladder, it says it's 20 feet. The angle formed by the ladder and the ground is 13, and then we're trying to find the distance from the base of the ladder, which means the bottom, to the house, which is x. So basically, I knew in the perspective of that 13 degrees, this side is opposite, this side's adjacent, and this side is the hypotenuse. So once you guys know that, then basically, well, I know there's information at the A and at the H. So we are going to be using cosine. So cosine of 13 is equal to adjacent, which is x, over hypotenuse, which is 20. And then we cross multiply. So then x times 1 is x. 20 times cosine 13 is 20 cosine 13. Put that into your guys' calculator and round to the nearest tenth for all of these, and we're going to get roughly 19.5 feet. So there's that. Number 4. Okay, so you guys actually had to do a drawing of this. Okay, you actually had to do a drawing. So a hot air balloon lifts 125 feet into the air. It was blown to the side and is connected to the ground by a rope. So this is the rope, right? And it's 125 feet above the ground. The rope and the ground, so this is the ground, right, form a 9-degree angle. How long is the rope? So basically, you guys are solving for x. So you guys are going to have to, I would suggest you guys do a drawing to do this. So here's our x value. Now let's label all of our stuff, right? So in the perspective of that angle, this side is adjacent, this side's opposite, and this side is the hypotenuse. So since there's information at opposite and hypotenuse, we're going to be using sine. So sine of 9 is equal to opposite over hypotenuse. So 125 over x. And then from there, we cross multiply to get this information. So x times sine 9, x sine 9, 125 times 1, 125. To isolate our x, divide both sides by sine of 9. So x is roughly going to be 799.1 feet. That's how long the rope is. Okay, so that's number 4. Okay, so for number 5. Now, for this one, I'm going to add some new stuff, okay? So, if we take a look at this triangle, okay? I'm going to erase this stuff so that there's a better idea on how you guys do this. So, my suggestion when you guys do this type of problem is, first, let's just get our 3 primary functions, sine, cosine, tangent, for each angle, okay? So, theta and alpha as our 2 angle measurements. So, I'm only looking into perspective of theta right now, right? So, I'm going to do sine theta, cosine theta, and tan theta, okay? Now, take a look, okay? Now, don't look at this one. Let's just look at theta. So for theta, in the perspective of theta, this is the opposite side, this is the hypotenuse, and this is the adjacent side, okay? So sine theta would be opposite over hypotenuse, so that would be B over C. Cosine theta would be adjacent over hypotenuse, which is A over C. And tan theta would be opposite over adjacent, so that's B over A. All right? So we labeled the triangle as if we're only looking at theta. Now let's bring back alpha, and let's erase these. Now, let's only look at the perspective of the alpha angle measurement, okay? So for alpha, this side would be the opposite in the perspective of the alpha angle measurement, okay? This side would be the adjacent, and this side would be the hypotenuse. So we first know we're going to make sine of alpha, cosine alpha, and tan of alpha. Now, sine of alpha would be opposite over hypotenuse, which would be A over C. Cosine of alpha would be adjacent over hypotenuse, which is B over C. And then tan of alpha would be opposite over adjacent, so that would be A over B. So that's how I would suggest you guys to do this, is look at each angle in the perspective of each angle and then make your opposite, adjacent, hypotenuse sides and then find all your ratios, okay? So now let's get back to this problem. Well, we have to look at which angle measurements ratios would give us A over C, right? This is the target. So when I look at my list, well, for the thetas, only looking at the thetas, I see that this one will give me A over C. And now when I look at my alphas, I see that this one will give me my A over C. So that's why your answer is going to be cosine theta and sine of alpha. All right. Now let's go for B, right? Now it says B over A. Well, when I only look at my thetas, right? Only looking at my thetas, I see that this one will give me B over A. Now let's look at our alphas, right? Our alpha angle measurements. Okay, this one is super close to giving us B over A. The only problem is that it's A over B. So in order to get B over A, we need to take the reciprocal of tangent. And I taught you guys the reciprocal of tangent is cotangent. So that's why it has to be cotangent of alpha, because then this one would flip, right? It would be the reciprocal. And then tan theta we already got, which was there. So the important thing is for you guys just do it in the perspective of, right? Make all your angle measurements and then look for what you have to do. So let's take a look at this one, okay? So don't look at this one. Do your thetas first, right? Okay, so sine theta, cosine theta, tan of theta. Okay, in the perspective of theta, this side is the opposite, y is your adjacent, and r is your hypotenuse. So sine of theta is opposite over hypotenuse for x over r. Cosine of theta is adjacent over hypotenuse, which is y over r. And tan of theta is opposite over adjacent for x over y. So we made all of our theta. Okay, so now let's not look at this. Let's only look at our alpha. So in the perspective of our alpha, this side is the adjacent, this side's hypotenuse, and this one's the opposite. So sine of alpha equals cosine alpha and tan of alpha. Okay, so sine of alpha is opposite over hypotenuse, so y over r. Cosine of alpha is adjacent over hypotenuse, so x over r. And tan of alpha is opposite over adjacent for y over x. So we made the core 3 trig functions for each angle measurement, theta and alpha. Now let's see what we have to look for. Okay, so we have to find r over y, right? So when I look only at my thetas, right, I see that this one is almost close to r over y. It's just we need to take the reciprocal. So it would be secant of theta, because secant is the reciprocal of the cosine function. So we just need to take the reciprocal of that, which is secant of theta. So we got our theta, now we gotta look at our alpha, right? When we look at our alpha, I notice that this is really close to resembling r over y. We just need to take the reciprocal. So the reciprocal of sine is basically cosecant, so cosecant of alpha. Okay, So let's look at our other one. Now we have to find this one, r over x. So back to my theta list. Looking at thetas, r over x, this one's really close. We just need to take the reciprocal. So the reciprocal of sine theta is cosecant theta. So cosecant theta is one answer. Now when you guys look at your alphas, this one is really close to being r over x. All we need to do is take the reciprocal. So the reciprocal of cosine is secant, so which is why we get secant of alpha. Okay, so that's how you guys do number 5, all right? Okay, so over here, okay, a water tower is located 325 feet from a building, which is why this length is 325 feet. From the top of the building, it is observed that the angle of elevation to the top of the tower is 39 degrees. So here's the top of the tower. This is the angle of elevation, so this is your guys' 39 degrees. And then it says how tall is the tower, so then you guys just know that that length is the height of the tower. So we're going to set it up. So 39 degrees in the perspective, this side right here is the opposite and this one is the adjacent. So the only one that uses opposite and adjacent is tangent. So that's why we use tan of 39 equals opposite over adjacent, which is x over 325. We cross multiply, so x times 1 is x, and then 325 times tan 39 is right there. And then, yeah, and then from there, we put down your calculator, and you guys should get 263.2 feet, which is the height of the tower. Lastly, right here for question number 7, so we have to solve for x, we gotta solve for theta, and then also find the ratio for all 6 trig functions. So first, we solve for x. Now notice that this is a right triangle, right? Which means to solve for x, we could use Pythagorean theorem. So a squared plus b squared equals c squared. Just remember, your c value is the hypotenuse. So this c is going to be, c squared is going to be 37 squared. And remember, you can interchange your guys' legs. So I just made a my x, so x squared, 35 my b for 35 squared. And then that's your c squared, right? Put those in your calculator. X squared plus 35 squared is x squared plus 1,225. 37 squared is 1,369. Subtract both sides by 1,225, and x squared is going to equal 144. Square root both sides, so you're going to get x is equal to 12. So once you guys know that x is 12, now you guys could find your 6 trig functions, right? In the perspective of this angle, we got opposite, adjacent, and hypotenuse. So sine of theta is opposite over hypotenuse for 12 over 37. Cosine theta is adjacent over hypotenuse for 35 over 37. And tan theta is opposite over adjacent for 12 over 35. And then remember, for cosecant, it's just the reciprocal of sine theta. So 37 over 12. Secant theta is the reciprocal of cosine theta. So take the reciprocal of cosine, and we're going to get 35 over 37. And tan theta, it's cotangent theta, is the reciprocal of tan theta. So 12 over 35, take reciprocal, 35 over 12. And then lastly, to find your guys' theta, all you guys have to do is use one of these 3 and then put that into your calculator, right? So as you guys can see, I used sine theta, so I took the sine inverse of both sides to get sine inverse of 12 over 37 to get around 18.9 degrees. If you guys use this one, you gotta use cosine inverse. And if you guys use this one, you gotta use tan inverse, right? I just decided to use sine inverse. And that's about it. So hopefully you guys you studied this, right? Just do your best on this, and you should be ready to go for the quiz. All right. Peace.